Hi. In this session, we will be discussing the method for calculating the last two digits of a number. Question on this model appeared in CAT 2008, and then after that also in several instances we have heard about questions of this type having been asked in CAT. There would be several methods for calculating the last two digits. Probably division by 100 would be the simplest in terms of understanding. However, from a practical perspective, from the perspective of being able to answer a question in the limited amount of time that we have, here's another method that would be very, very useful for us. For the last two digits of any number, let us say the question is 7 to the power 2008. This was the question that appeared in CAT. What will be the last two digits of this number? I could look at calculating the last two digits and of 7, then 7 square, then 7 cube, then 7 to the power 4, and trying to identify a general pattern in the last two digits. That could be one way of going about this. However, this method may not always be applicable, because in case the pattern is not very clearly discernible, this could get very, very complicated. So therefore, here is an alternate method which will be very, very useful for us. Let us say, as far as the last digit is concerned, the last digit of any number can be either it will be odd, so it will be 1, 3, 5, 7 and 9, or it will be even, so this will become 2, 4, 6, 8 and 0. We will put 0 in a separate category. We will put 5 in a separate category, and so these are the four categories that we are looking at. Let's start with the first one. If the last digit of a number is 0, so let's say I'm looking at 70 to the power whatever. If the last digit is 0, in any higher power, there will be the second last digit will also become 0. So therefore, if the last digit is 0, very clearly the last two digits of any power will always be 0. If the last digit is 5, so let's say I'm looking at 15. 15 to the power 1 is equal to 15. 15 square is equal to 225. So this becomes 25. 15 cube, this will be 25 multiplied by 15. As far as the last two digits are concerned, they will depend only on the last two digits of the number, so I do not have to bother about whatever came before that. 25 into 15, this will become 5 into 5 is 25, and 2 plus 1, 3, 5 is 15, 15 plus 2 is 7, so this becomes 75. 15 to the power 4 will be 75 into 25, into 15, so this will become again 25. And so on and so forth. In general, what we will observe is that 15 to the powers, they will alternate between 25 and 75. On the other hand, if I look at the higher powers of 25, 25 square is 625, 625 again becomes 25, so 25 again multiplied by 25 would still be 25, so it will always remain 25. In general, if the last digit is 5, then if the second last digit is even, then it will always be 25. On the other hand, if it is odd, then if the power is odd, so for example here we saw 15 cube is a odd power, 15 to the power 5 would be an odd power, so if the power is odd, then the last two digits would be 75, and if the power is even, then the last two digits would be 25. So 75, 25, it will keep alternating. Whenever the power is odd, it would be 75, whenever the power is even, it will be 25. So with this, powers of 15 would also be sorted. Next, we look at the general method for calculating the remainder, the last two digits when the last digit is odd. First things first, if the last digit is 1, then there is a very simple method by which we can calculate the last two digits of any power, and then for 3, 7 and 9 the same method can be extended. So what we do is, let us say first as an example, if I am looking at 23 to the power 137, what will be the last two digits of this number? To calculate the last two, I'm sorry, I'm looking at example of 1, so let's say I'm looking at 21 to the power 137. Obviously the last digit of any power will always be 1. The second last digit will be this multiplied by this. So 2 into 7 is 14, so the last two digits of this number will be 41. If this was 9, it would have been 2 into 9, 8. If it was 121, then also I would have focused only on the 2. I'm interested only in the second last digit. Second last digit multiplied by the last digit of the power, that defines the second last digit of any power. In general, if the number is a1 raised to the power, let's say xb, where x could be any number of digits on this side, a is the second last digit, then the last two digits of the power would be a into b followed by 1. So another example, let's say I'm looking at 31 raised to the power 43. The last two digits of this number will be, last digit is 1, 3 into 3 is 9, so 91. 91 will be the last two digits for this number. So that's about the numbers which are ending in 1. Next, let's look at numbers which are ending in a 3, 7 or a 9. For numbers which are ending in 3, 7 or 9, if we look at their power cycles, we realize that 1 appears at the second or the fourth position in their power cycles. In case of 3, the power cycle is 3, 3 3 is 9, 9 3 is 27, 7 3 is 21. So 3971, 3 to the power 4 will have a last digit 1. Similarly, 7, 7 7 is 49, 9 7 is 63, 3 7 is 21, 7 to the power 4 will have a last digit 1. 9 is 9, 1, so 9 is square will have a last digit 1. So what we can do is, whatever power I'm trying to raise 3 to, I'll express that as 3 to the power 4 whole to the power something. Once I've written that as 3 to the power 4 whole to the power something, I'll get the last digit as 1. And then the normal method for numbers ending in 1, that can be applied. Let's take an example. Suppose I'm looking at 13 to the power 40. What will be the last two digits of this number? In case of 3, I know that the power cycle is 4. If the power cycle is 4, I'll write this as 13 to the power 4 whole to the power 10. Once I write this as 13 to the power 4 whole to the power 10, I can calculate the last two digits of this, which will not be very difficult. Once I have calculated the last two digits of this, I'll use the formula for 1 and I will get my answer. So now let us focus on calculating the last two digits of 13 to the power 4. 13 is square is 169. 69 is square, I don't know, it will be a little difficult for us to calculate the value of 69 is square. So therefore there is one more method that we can use here. The last two digits of k square are equal to 50 minus k square are equal to 50 plus k square are equal to 100 minus k square are equal to 100 plus k square. So just to reiterate my point, let us say I'm looking at 13. 13 is square is equivalent to 50 minus 13 is 37, so this is equivalent to 37 is square, which is equivalent to 50 plus 13 is 63, 63 is square, which is equivalent to 100 minus 13 is 87, so 87 is square, which is equivalent to 100 plus 13 is 113 square. This is empirically true, and this can be verified also. So 13 is square, 37 is square, the last two digits will all be the same. Now applying the idea here, 13 square was 169, that becomes 69. 69 is 19. 50 plus 19 is 69. So this becomes 69. 69 is 50 plus 19, so this will become 19 square. Now 19 square is 361, so this will give me 61. Once I've got 61 from here, so this is equivalent to 61 to the power 10. 6 into 0 is 0. 0, last digit is 1. 0, 1. 0, 1 is my answer. Let's take another example. Let us say I'm looking at 17, let's make it 27. I'm looking at 27 to the power 142. Now 7, the cyclicity is again 4, so I'll write this number as 27 to the power 4 whole to the power 142 divided by 4 is 4 3s are 12 and 2, so 4 5s are 20 multiplied by 27 square. Now as far as this first part is concerned, 27 is same as 23, or we can look at 27 also. This becomes 729. 729 square, so here this will become 27 square is equal to 729, so this becomes 29. 29 square is same as 50 minus 29 is 21. 21 square is 441, so this is equivalent to 41. 41 to the power 35 multiplied by 27 square, which is 29. Now 41 is 4 5s are 20, 0 1, 0 1 multiplied by 29 is equal to 29. So 29 would be my answer. So this is about combination that also we have seen. Similarly, if the last digit was 9, then also the same concept would have been applied, and with this we'll get the last two digits when the last digit of a number is 1, 3, 7 or 9. Once we are done with 1, 3, 7 and 9, the last category remains for us 2, 4, 6 and 8. For 2, 4, 6 and 8, what we understand is 2 to the power 10 is equal to 1024. 2 to the power 20 is equal to, now if I'm looking at 2 to the power 20, 2 to the power 20 is 2 to the power 10 square. 24 square is 576, so 2 to the power 20 last two digits, if the last two digits here are 24, the last two digits of 2 to the power 20 would be 76. Once I get the last two digits of 2 to the power 20 as 76, next I'm looking at 2 to the power 30. 2 to the power 30 would be same as 2 to the power 20 multiplied by 2 to the power 10. 20 plus 10 would be equal to 30. 76 into 24 is 24. Next one, 2 to the power 40. 2 to the power 40 would be equivalent to 2 to the power 20 square. 76 square, this will also give me 76. In general, 2 to the power 10 whole to the power odd power is equivalent to 24, and 2 to the power 10 whole to the power even power is equivalent to 76. 2 to the power 10 odd power is 24, 2 to the power 10 even power is 76. So now on the basis of this, let us say I have to find the last two digits of 2 to the power 183. For 2 to the power 183, this will become 2 to the power 10 whole to the power 18 multiplied by 2 to the power 3. Now 2 to the power 10, any even power is 76, so this will become 76 multiplied by 2 cube is 08. Also 76 multiplied by any power of 2, the last two digits they remain the same. So 76 multiplied by 08, this will give me 08. 08 will be my answer. This method should be, the only thing to remember here is 2 to the power 10, odd power is 24, 2 to the power 10, even power is 76. Now whatever power of 2 is given, we can always convert it into 2 to the power 10 to the power odd or even term. If the term is odd, we take 24, if the term is even, we take 76. Remaining ones, they can be multiplied as such, and we are sorted with 2 also. Now as far as 4, 6 and 8 are concerned, any number which ends in a 4, 6 or a 8, it can always be converted into a power of 2. Rephrase. Any even number, it can always be written as 2 to the power x multiplied by some odd number. Any even number, let's say I'm looking at 14. 14 is equal to 2 into 7. I'm looking at 28. 28 is equal to 2 square into 7. I'm looking at 56. 56 again will be 2 to the power a multiplied by some odd number. So any number can be written as 2 to the power something multiplied by an odd number. Because any even number can be written as 2 to the power something into odd number. For 2 to the power something, I'll use this method. For the remaining part, we'll use the method that we had discussed for 1, 3, 5, 7, 9. And with that, the two can be combined and we'll have our answer. Let's take an example. We have to calculate the last two digits of these 5 questions are given. Probably you can pause the video here and go through these questions, try answering them, and then revert here. The first one, 20 to the power 34. Naturally, if the last digit is 0, any power raised, the last two digits will be 0, 0. So this will give me 0, 0. 25. 25, it's a 2 is an even number raised to the power anything, it will always be 25. So this one will remain 25 only. 21, 2 into 4 is 8. Last digit will remain 1. 29 to the power 34. 29, the cyclicity is 2. 91, 91, 91. So I'll write this as 29 square whole to the power 14. I'm sorry, 17. Which is equivalent to 29 is 21, which is 441. So this is equivalent to 41 to the power 17. 7 4s are 28, and followed by 1. So this will also become 81. The last one, 20 to the power 34. This is an even number. This can be broken into 2 to the power 34 multiplied by 11 to the power 34. 2 to the power 34 is 2 to the power 10 whole to the power 3 multiplied by 2 to the power 4 multiplied by 11 to the power 34. This is 1 into 4, 4, 41. This would be equal to 2 to the power 10, odd power is 24. 24 multiplied by 2 to the power 4 is 16 multiplied by 41. 24 into 16, 16 4 is 64. 6, 16 to 32, 32 plus 6 is 38. So this becomes 84. 84 multiplied by 41. This would be equal to 1 4 is 4. And so okay, at this point, for calculating the last two digits, it is always better to use the digit method for calculation, because if I was to multiply the complete number, the effort required will be more. So therefore what we do is 84 and 41. So from here I will get 1 into 4, 4 is the last digit. Second last digit, 8 into 1, 8, 4 4 is 16, 16 plus 8 is 24, so this becomes 44. So the last two digits of this number will be 44. Answer.